Right, good afternoon, second year. Today what we're going to be doing is we're going to be continuing our work on comparing fractions, okay? So we kind of introduced this idea yesterday. First of all, comparing fractions with the same denominator, which is actually very straightforward to do. For example, if I write these two fractions here down, 3/5 and 4/5, you can obviously tell just from the two numerators here which one would be the bigger one. It would be the 4/5, wouldn't it? So if I was reading this left to right, I need to put one of these symbols, remember, into this area here, okay? So is 3/5 greater than, is it less than, or is it equal to 4/5? Well, it's obviously less than, isn't it? And less than, remember, is that symbol there. Okay, so we're going to take this one step further today. We're going to keep on practicing comparing fractions with different denominators, all right? So do a couple of examples just now. So do you want to copy this down just now for me? If you want to pause the video just now, just take a new heading of comparing fractions, write in our three different symbols here and what they mean just now. If you want to pause the video just now and do that, that's fine. Right, okay, we're going to continue now with an example. Okay, so just put example 1 down as a little subheading, please. And if you would prefer to watch the full video then copy down, that's fine. If you want to pause it as we're doing it, that's totally fine as well. Okay, so first one we'll do is we're going to compare the fraction 4/5 and we're going to compare it with 9/10. Okay, so just now you need to prove to me in maths that you understand which one is greater, which one is smaller. Okay, so it's not good enough just to look at these two and then pick one. You need to prove it. Why is that one the bigger one? Okay, so remember we spoke about this yesterday. It's a very common mistake that people make to first of all look at it and think, right, there's a larger number on that numerator just now, so that one must be bigger. Remember, that's not always the case. So just now, you can see here that our two denominators are different, aren't they? This one's 5 and this one's 10. So this one here says 4/5. This one here says 9/10. So we need to make those into the same denominator. So I'm thinking to myself just now, right, and this is a good method for doing this question. First of all, what to do is we'll just draw in two empty fractions, okay, where we're going to place a number here on the top with a number here on the bottom. Same with this one, we're going to compare it to 9/10, so we're going to write a number here, and we're going to write a number in the denominator there, okay? So I want you to write in your empty fractions just now. So just now I'm thinking that I need to make both of these denominators the exact same number, so that I can easily look at the two numerators after it and compare, like we've done in that very first example there, right? So just now I'm thinking, which number do I know that 5 goes into it and also 10 goes into it? So there's obviously a few examples you could use. I'm always thinking we should always be trying the smallest one. Okay, so which the smallest number that 5 goes into it and 10 goes into it? So 10, wouldn't it? Because 10 goes into 10 and also 5 goes into 10. So remember, if you picked a larger number, for example, you could pick 20 because 10 goes into 20 and 5 goes into 20, or you could pick 50. 50, like 10 goes into 50 and 5 goes into 50. I'm going to pick 10 but because it's the smallest, and the smallest number you pick here will require the less work. Okay, so I've picked my new denominator here of 10. So I'm thinking just now that I'm comparing this 4/5 one to this one, and I'm comparing 9/10 here to this one here, okay? So see this 10 here, I've not done anything to that, have I? So I've not actually changed that fraction at all. That can stay there as 9/10, so that's fine. This one, however, here, this one's changed, isn't it? First of all, I had the denominator of 5, and my new denominator is 10. So what have I multiplied 5 by to get 10? I multiplied it by 2. And remember, whatever we do to our denominator, what must we also do to our numerator? We must also multiply that by 2. So what is 4 times 2 on my numerator? My new numerator will become 8. So now do you see how it's very easy to compare which one is greater, which one is smaller? So I've got 8/10 and I'm comparing it with 9/10. So 8/10 is obviously less than 9/10, isn't it? So what's our symbol for less than? It is this one here. Okay? Right, so copy that down, that example just now. If you want to pause the video just now to do that, and then we're going to continue with another example just now. Right, this next example is going to be example 2. Right, so we'll go for 2/4, and we're going to compare it to 4/8. Okay, so 2 over 4, 2 quarters, we're going to compare it to 4 over 8. So just now remember, it's not good enough just to think, right, which one's bigger here and pick at this point in maths. In order to get the marks in this question, you need to prove, you need to show you're working, okay? So just now you can clearly see again, we've got different denominators here, don't we? This one here's 4 at the denominator, and this one here's the 8. So let's write in our empty fractions just now. Right, so I'm thinking to myself here, right, which number do I know that, because 4 goes into it and also 8 goes into it. So remember, there's a couple of different examples here you could use. So you could use 8. Remember, 8 would be the number I would choose here because 4 goes into 8, and obviously we know 8 goes into 8, doesn't it? So thinking of other numbers you could have picked there, you could have picked 16. You could have picked 24. Doesn't actually matter, okay? But remember, I'm wanting to pick the lowest common multiple of these things because that means I've got the less work to do. Okay, so again, I'm comparing these fractions just now. This time we'll start with this one here. What have I multiplied the 4 by, my old denominator, to get my new denominator? I've multiplied it by 2 again. So what does that mean I need to do to my numerator? 2 times 2 as well, don't I? So what's 2 times 2? Quite an easy one. It would be 4 over 8. Now I'm comparing it to this one. Have I done anything to this one? No, the 8's just still an 8, isn't it? So that means I can't change my numerator either. So I've got 4/8 and 4/8. So obviously we know those are equal to each other, aren't we? So we can put our equal to symbol in there. Okay? So remember, when you're looking at questions like these, what you have to do is you have to make the same denominator. It's called finding a common denominator. Remember, common in maths just means the same. Okay? So again, if you want to pause this just now and copy down that example, it's fine. I'm going to show you one more example before you go and try the questions. Right, so let's go for example 3 just now. Okay, so I'm going to go this time with 5/12, and we will go for 3/6. Okay, so 5/12 and 3/6. Okay, so let's bring an equal sign down here just now. Again, we can clearly see different denominators. Okay, so let's write in our empty fractions. Right, so I'm thinking numbers on my denominator I can make. Okay, so numbers that 12 goes into it and also 6 goes into it. So again, you could think of really hard ones. You could think, for example, you could think 24 because 12 goes into 24 and 6 goes into 24. But remember, we're always wanting to find the lowest common multiple between these things. Okay, so those common multiple I would pick here would be 12 because I know that 12 goes into 12. And 6 goes into 12, doesn't it? Because 12 is double 6. Right, so I'm starting here just now. I'm thinking, have I done anything to 12 here to get 12? No, I haven't. Okay, so that one there's just going to stay as 5/12. Now I'm looking to this example here. I'm comparing these two denominators here. So I first of all had 6 and now I've got 12. So what have I multiplied 6 by to get 12? I multiplied it by 2, haven't I? Because I've done that to my denominator, but what must I also do to my numerator? I must also times that by 2. Okay? So my new numerator 3 multiplied by 2 gives me 6. Alright, so I'm looking at these two things just now. 5/12 and 6/12. You see now it's very easy to compare them. Which one's smaller, 5/12 or 6/12? So obviously the 5/12, isn't it? So 5/12 is less than 6/12. Okay? So once you copy down this example, you're going to be trying the questions in the worksheet in your jotter, okay? So you're not writing on the worksheet, you're going to write them in your jotter. So first of all, I want question. I want to show you're working, what you're multiplying numerator and denominator by, and then what your answer is. Remembering to put in what your symbol is in here. Is it less than, is it greater than, or is it equal to? Okay? Cheers, guys.